So now we'll be doing digital experiments. We'll demonstrate how to do that. In the desktop folder, you need to make your own folder. We have made our own. So MSM underscore VLSI is our folder. So I'll go inside that. Here in the inside your folder, there are many files. So I'll teach you how to do from the beginning. You need to create an empty file, a Verilog file. So right click, create document, empty file. You need to name it. So whatever experiment that we're going to do, we need to name it as such. And .v is mandatory because it's a Verilog file. So once you type in that in and press enter, the file is here. So it's empty. We need to open it. We need to open it with gedit, gedit. So gedit. So the file gets opened here. Here we need to type in the code. So we already have a folder file which is where you have typed the code. So adder.v is our files. I'll open that. So this is the code. So we already typed that. So in parallel to this, we need to create one more file. And look at here, adder underscore tb.v. So again a .v file. So I taught you how to create a file, create document, empty file. So type some name. .v is mandatory, but in this we need to add underscore tb. So underscore anything underscore tb.v. So such a file should be created. So I told you I already created one. So adder underscore tb.v is this file. Open a gedit. So we have typed the code for the test bench as well. So adder.v or full adder underscore tb, the test bench code for the same. So we're doing adder. Now once you type in the code, we need to
click check and save.
Click save. Click save. Now we need to go to back our folder. In the open space, we need to launch Cadence here. So right click, open in terminal. Now we need to type in a command csh following source and welcome Cadence tool suite. Here we need to type in this command nc launch space -new. The window opens. Click multiple step, the first one, create cds.lib file. Let's click that. Now here we need to create a cds file. So type in any name, cds 9 I've chosen. Save. Check the third one, don't include any libraries. Okay. Create cds.lib file. No, we already created one. So once we're done, we can click OK. Click yes. So our section opens, nc launch window. Now we need to compile all that files that we created. So we have two files, adder.v and adder underscore tb.v. We need to remember the file name. So adder.v will be compiled using the vlog button here. So click on it and click vlog. So the file is compiled successfully. So no errors there in the code. Similarly, adder underscore tb.v, click there and vlog. No errors in the code. So I'll show you that. So this is the codes that we typed and this is the files. So those files are existing here. Those same files. So we launched Cadence, and in the nc launch window we compile them. Once done, we need to go to this section, work lib plus icon. So we'll have our two modules here. So I'll show you that. These are the adder1 underscore tb module inside the test bench file, and f full adder module inside the adder.v file. So in the nc launch window, bottom task, we can find that always. In the work lib, adder, we'll just elaborate both of them. So this button, launch elaborate button, the process runs and successful. Again process runs and successful again. So inside snapshots, we need to click the underscore tb module. So once we highlight that, click run. The simulation analysis runs and then a window appears. In this section, we'll have our tb module underscore tb. Click on that, right click, send to waveform window. So waveform window appears. This is the play button. We just click on that and the output appears. This is the waveform, the output window.
Yeah.
So we got our output waveform. Now furthermore, we need to check the power, performance and area.
PPA.
So we'll go to our folder, our main folder, MSM VLSI, found down. So before doing any step, we need to ensure some folders or files are there, such as if we see a constraints underscore file, and there should be an RC script file. Here we find an RC underscore script dot TCL.
Go to that rc
So-
underscore script dot ACL.
Right click, open a gedit. So here we see the RC underscore script dot TCL. Let everything be same, no need to change anything. But here if you see, adder.v is put, so that is good, because adder.v is the file, is the main file of our adder
Program.
Therefore that same name adder.v should be present here. If the file name is different, then this has to get changed. So again we'll go back to MSM, our main folder. So constraints file is also there. So this is something that is a constraints file that is existent for any circuit that we build, which has two inputs and an output, two inputs and two output. So we'll close this. We have all the files required, RC script and constraints. So going back to the
Terminal.
window. Here we need to click Control Z first, so that
Next.
suspends the session. Next we need to type in genus, GENU.
Yes.
Yes. Wait for some time for the two scripts to load. So it got loaded. Now what we need to type is, we need to load our RC script file here. So source space RC underscore script dot TCL. So our source space RC underscore script dot TCL. So all the processes happens. We'll type in report power. So we get our power report. We need to note down these values. So instance is full adder, cells 1, leakage power in terms of nanowatt, and dynamic power, total power. So similarly we can
Report area.
So area gets reported.
After that,
After
timings.
that, we need to report time. So now we need to report time. So type in report. So we can go to our RC script file to get that report underscore timing space. So we type in the last line, report underscore timing space hyphen unconstrained. Let's just verify the unconstrained, report underscore timing space hyphen unconstrained. Let's try that. So enter. So here we get the output. Now what we need to note is the data path 304. We need to note that down as the time output.
Yeah.
Once we completed the power performance in area requirement, next we need to open up the schematic. So type in command GUI underscore show.
Show.
This will open up a window and navigate to the plus icon mentioned here in that schematic. So here we get our full adder schematic, A, B, C, and S, sum and out.
Similarly, follow the same steps for all the remaining experiments.